This is geometry. This is the semester 1 exam review, working on unit 3. This is the introduction to proofs. We're going to talk about if the statement is true or false, and if it's false, we're going to give a counterexample. If a polygon has 3 sides, then it is an equilateral triangle. So the question is, does every polygon that have 3 sides require it to be an equilateral triangle? Equilateral means all sides congruent. You need to know your vocabulary. So equilateral, all sides congruent. So I can draw a picture that perhaps all 3 sides are different. I could probably draw a picture where 2 sides were the same, and of course 3 sides were the same. So this would be false, and this would be our counterexample. We'll write a converse of the statement. Tell whether the converse is true or false. If a polygon is a rectangle, then it is a parallelogram. A rectangle is always a parallelogram. It's going to hold all the same properties of a parallelogram. But the converse is what it's asking us to do. If a polygon is a parallelogram, then it is a rectangle. So if you draw a parallelogram, did you have to draw a rectangle? And I can draw a parallelogram that doesn't have 90-degree angles. It's a parallelogram because I have 2 sets of parallel sides. So this would be false, because you can draw a parallelogram that is not a rectangle. It is possible. So we're going to name the property. So when you have the same figure, angle J is congruent to angle J, that's called reflexive property. Here we have if angle P is congruent to angle R, and angle R is congruent to angle S, then angle P is congruent to angle S. That's the transitive property of congruence. Be sure you use congruence and not equality, because these are congruent symbols. We often abbreviate that as POC. If YZ is congruent to AN, and AN is congruent to QV, then YZ is congruent to QV. Again, that's the transitive property of congruence. Here we know that angle 1 and angle 2 are complementary angles. Complementary means a sum of 90 degrees. We're given the measure of angle 1. What is the measure of angle 2? Complementary, remember, good on your note card, that it is a sum of 90 degrees. If the measure of angle 1 is 35, what is the measurement of angle 2? Measure of angle 2 equals 55. This case, still, the measurement of angle 1 plus the measurement of angle 2 should equal 90 degrees. If the measurement of angle 1 is 16.5, what is the measurement of 2? So we'll subtract and we'll get 73.5. One way to do subtraction is actually to do it backwards and look at addition. 73 and what make 90? 73 plus 10 gets you to 83, plus 6 gets you to 89, and a half gets you to the 90. On the next page, we're looking at angles 3 and 4, and they're supposed to be supplementary. That means a sum of 180. We'll be given the measure of angle 3, and we're looking for the measure of angle 4. So I know the measure of angle 3 plus the measure of angle 4 add up to equal 180. Plug in 115, subtract it, and we'll get 65 degrees. On this side, the measurement of angle 3 plus the measurement of angle 4 is still going to add up to 180 because they are supplementary. We plug in the 34, subtract it, measure of angle 4 would have to be a 146. So here we have this figure, and we're supposed to find the measurement of angle DEG and angle GEF. So we have to decide what is the relationship about these angles. What do they do? Do they equal each other? Do they add up to 180? Do they add up to 90? What are their relationship? Well, because we have a straight line, we know two angles will add up to 180 degrees. So I know the measurement of angle DEG plus the measurement of angle GEF adds up to 180. This is called a linear pair because they're two angles side by side, meaning adjacent. They're adjacent angles that are supplementary. They're a linear pair. So I have x minus 6 and I have 3x plus 42. So collecting our like terms, notice we don't have to do the opposite sign. We don't have to say minus x minus x. We're on the same side of the equal sign, so it's just 1x plus 3x is 4x. Negative 6 plus 42 gives me a positive 36. $144. So when we divide by 4, I know my x is going to be 36. And we're supposed to find the measurement of DEG. So DEG, the measurement of angle DEG is going to be 36 minus 6, which is 30. The measurement of angle GEF is going to be 3 times 36 plus 42 more. So 3 times 36 is 108. 108 and 42 is 150. So does 30 and 150 add up to 180? Why, yes it does. So here's our proof. We're supposed to be figuring out. We start with our given, and it says that AB is congruent to CD. So those are the same measure. You want to look at your given, you want to look at the picture, and try to figure out how can we come to this conclusion. You want to do this before you look at the two-column proof. So we look at AC. We look at BD. How can AC and BD be the same length if AB and CD are guaranteed to be equal? Well, it looks like if we're going to go over a certain amount and then BC, that's the same thing as if we come from the right side. We go a certain amount and then BC. So it looks like we're adding BC onto parts that are already equal, and then of course it's equal. So we have our plan on how we can do this. And look here, the first step besides the given is that they are adding the same amount to both pieces. So that's called addition property of equality. You can call that POE for a shortcut, addition POE. This next portion, notice that there's a colon in here. They say that AB, look for where that is, BC equals AC. The two small parts equal the big part. The two small parts equal the big part. That is called segment addition postulate. Here, looking at what's different between 3 and 4, this whole portion is exactly the same. Only thing that's changed are these two. Why did we change the AB and call it a CD? That's because they were equal in the very beginning. So that's called substitution property. Then we have AC equal to BD, and if you notice, AC is equal to this value. That value is again written right here, so that is also equal to BD. So AC has to equal BD. That's an example of the transitive property of equality. We don't typically say substitution property of equality. We just say property. Transitive, you do need to be careful if it is reflexive or equality. So for this next one, we're given our information here. Like we talked about before, there's a linear pair. There are two angles that make up this straight line, and they're supposed to be the same measurement. If they make a straight line, then I know they add up to 180. If they're the same measurement, they must both be 90 degrees, because 90 degrees and 90 degrees makes up that straight line. Well, if they're 90, then they are right angles, and right angles form perpendicular. So that's my plan or my explanation in my own words how that is possible. How can you get that G is perpendicular to H? So going through our proof, we know our given, supplementary. So if linear pair, then supplementary angles. Remember, the if has to happen earlier. The then is happening right now. Now we see two angles adding up to 180. So if supplementary, then we know that it adds up to 180. If supplementary, we said they were supplementary earlier, then now we're going to say that they equal 180. 1 is congruent to 2, that came from the given. Now the only thing that we're doing here in this step is saying that we're going from angle 1 is congruent to angle 2 to the measure of angle 1 is equal. So if congruent angles, then equal angles. The reason why we had to switch that over to equals is because we want to substitute that back into this equation, and you can't substitute in a congruent statement. You have to substitute in an equality statement. So instead of saying 1 plus 2 adds up to 180, we're going to substitute the 1 in place of the 2 and call it 1 plus 1 equals 180. And then they've thrown in this step for us. They're combining like terms. You can also call it the distributive property. It's actually backwards from the distributive property, but that's often what it's referred to. We have our two terms, and instead of saying that we have 1 plus 1, we're going to say that we have 2 times the measure of angle 1. How can we get 90? That's the division property of equality. If 90-degree angle, then a right angle. If comes before, then happens right now. It makes the if-then statement so much easier to write. If right angle, then perpendicular lines. We know that G and H represent lines, so we would call them perpendicular lines. For this last proof, at least for number 13, we're looking at our given information, which is angle 3 and 4. They're congruent. So that's why there's a curve, an angle tick mark in there. What we need to come up with is that the angle 1 is congruent to angle 2. Now, it doesn't have anything to do with the triangle shape. What do you see when you're making your plan? You can't do a proof just by writing it down right away. You have to make a plan. You've got to read it, understand it, and try to understand how you come up with what they're trying to prove. Well, I recognize that here we have big lines that are crossing, that make a big X. And if you make a big X, then you could have vertical angles. So 1 and 3 have to be the same measurement. 1 and 4 have to be the same measurement. So now I know that because 3 and 4 were the same, 1 and 2 are now the same. They're all the same measurement. So I have my given. 1 and 3 it says. So if vertical angles, this is the one example where the if is not written before it, but it's written up in the picture. If vertical angles, then congruent angles. Here we have angle 1 is congruent to angle 4. A way to recognize that is if A, we can call that A, if A equals B and B equals C, then my A has to equal the C. That's following that transitive property of congruence. And then I can get rid of those markings. And we can try that again, because now I got to come up with a reason why 1 and 2. See if I have the same pattern. If A equals B, and B, that same angle 4, is congruent to 2, which is something different, so we'll call it C, then A has to be equal to C. If A equals B and B equals C, then A equals C. Okay, on the next page, we're looking at and classifying what type of angles we have. There are 4 different types of angles that we're going to talk about. Corresponding angles, they form an F shape. Alternate interior angles, they form a Z shape. Alternate exterior angles, it's funny, they don't necessarily form much of a shape. When highlighting them, they open up like that. And then consecutive interior often form like a C shape. Now sometimes the F can be upside down or flipped. The Z can look more like an N. It all depends on which angles we're picking. But it's going to make a zigzag shape. It's going to make a C, or maybe that look more like an N if it was turned sideways. Let's look at angles 1 and 9. Looking at 1 and 9, there's 9, and there's angle 1. That would form an F shape. So they're both on top and to the left of the vertex. So that's called corresponding. Eight and 13. If you trace out 8, and you trace out 13, you see that it's going to make that big C shape. It's kind of backwards C, but it makes a C shape, which is consecutive interior. They're both inside the 2 parallel lines, and they're on the same side of the equal sign. Both on the same side of the transversal. 6 and 16. This is looking a lot like our alternate exterior. They make this V shape up here. They make a different V shape down here. They're not touching like the other ones seem to zigzag and they overlap and so forth. Here, they're on the outside of your 2 lines on opposite sides of the transversal. Alternate exterior. 4 and 10. They are on opposite sides of this transversal, but they make this zigzag shape. So the zigzag shape is alternate interior. 8 and 16. 8 and 16 make this F shape. It's a bit backwards, but it's an F shape. So we'll call it corresponding. And we'll finish with 10 and 13. So tracing out what looks like 10 and tracing out what looks like 13. If you see, they're both inside. They're both on the same side of this transversal. They're making the C type shape. Looks more like a U from this point of view. It's called consecutive interior. Now, for these angles to really mean something, the original lines need to be parallel to each other. And if you're parallel and then have a transversal, these angles start to be made. So if two parallel lines are intersected by a transversal, then alternate interior angles. What that's going to look like is if you have two lines that are parallel and you have a transversal, then alternate interior, which would be that, makes a zigzag. They are congruent. But if you have two parallel lines and a transversal, the consecutive interior are going to be supplementary. Here again, you have two lines that are parallel with the transversal. The corresponding angles, they're going to be congruent. And then to finish up with alternate exterior, those would be considered alternate exterior. They're also going to be congruent. So using that, we look here at number 24, we have to identify what type of angles these are. We see the arrows in the middle of the lines. That tells us that the lines are parallel. If two lines are parallel, then alternate interior angles are congruent. So it's important to understand what the theorem is. So we would say that 6x equals 3x plus 12. So we'll minus our 3, and x equals 4. 12 divided by 3 is 4. This picture is a little bit different. Look where the angles are. Look at the shape that makes. More like a C shape. If two lines are parallel, then consecutive interior, that's the name of these angles, consecutive interior angles are supplementary. This is the tricky one. This is the only one that's not congruent, are the consecutive interior. They are supplementary. They don't add up to the same measurement. You could tell back here that consecutive interior angles wouldn't be the same measurement. So if they're supplementary, then we set them equal to 180. 2x divided by 2. So x goes into that 9 times with 1 left over, 5.5 times. It looks like 95.5. Let's look at what we have for number 26. Again, this is a linear pair because it's two angles that are making up this straight line. They're adjacent and they're supplementary. So I know that the 2x plus 9 plus the 10x plus 15, it adds up to 180 degrees. It gives me 12x and 24. Subtract the 24 to get 156. Divide by the 12. 12 goes into 15 one time with 3 left over, and goes into 36 3 times. So x is going to be 13. Number 27. What's tricky about this one is you need to really look at the picture and figure out where are the variables that you're working with. The x's on opposite sides are not across from they're not next to each other. They're, maybe you'd call it a cross. Notice how this makes a big X, and they're on opposite sides of this big X. They are vertical angles. In this case, the vertical angles have the same variable. Vertical angles are congruent. So I'm going to set them equal to each other. Subtract. And figure out that x is 9. The y value, those are also across from each other. So those are also vertical angles. So I'm going to subtract the 16 to get 3y, that equals negative 27, divide, and it looks like this comes out to be negative 9. Okay, working on this 2-column proof. Look at the given information. Look at what you're trying to prove. We see that we have our 2 lines that are parallel. That's what the arrows represent. Angle 1 is supposed to be congruent to angle 2, so we can put our tick marks on your picture. Now what we need to prove is that P is congruent to R, and how would we know that? Well, if G and H are parallel, then I know corresponding angles are supposed to be congruent. So this is going to get the same curve. And then we can say the converse. We'll say if alternate exterior angles are congruent, then the lines are parallel. I can't use parallel because I don't know they're parallel. But they're congruent, so therefore the lines have to be parallel. So we'll start out with our given. We know that 1 is congruent to 3 because if parallel lines, then what type of angles are 1 and 3? Then corresponding angles are congruent. 1 and 2 were all up here part of the given. 2 and 3 are congruent. Well, if 2, let's call that A, is congruent to 1, and 1 is congruent to something new, which is C, 3, if A is congruent to B and B is congruent to C, then A is congruent to C. That's called the transitive property of congruence. P is parallel to R. How do we know that? If alternate exterior angles are congruent, and that's what we had prior to it. We talked about how 2 and 3 were alternate exterior. Then the lines are parallel. Last one for this Unit 3. So Unit 3 was a long one. Okay, we're given two parallel lines. They have the arrows. We have two angles that are congruent to each other. Pretty similar to the one we just did, but different still. So make your marks on your picture. How can we get that P is parallel, there should be an R right here, P is parallel to line R? Well, it looks like if these lines are parallel to each other, then I know alternate interior angles have to be congruent. And then that's going to show that 3 is the same as 2. If alternate interior angles are congruent here, then I know P and R would have to be parallel. So that's my plan on how I'm going to get there. You have to make a plan. Start out with your given. We know that 1 is congruent to 3 if parallel lines, then alternate interior angles are congruent. The way we know that 1 and 2 are congruent is because that was given. We're going to do that transitive again. A equals B and B equals C, then A equals C. And now, like we talked about, now 2 and 3 are the same measurement. They're considered alternate interior. They make that zigzag. If alternate interior angles are congruent, then the lines are parallel. That concludes Unit 3.